Hello class, how are you? I hope you are doing fine, okay? So today we are going to learn the new chapter, which is chapter 6, Angles and Tangents of Circles. Okay, I hope you still remember what have you learned in Form 2 regarding circles. Okay, so in order to help you to recall back what is circle, I made some slides to recall back. Okay, so let's start. What is circle? Of course, it is a round shape, right? But what more can you say about circle, apart from round shape? Okay, actually circle is a round shape made up of points which are equidistant from a fixed point called the center. Okay, so it is a round shape made up of points. You see a lot of points here, and all these points are actually equidistant from a fixed point at the center here. Okay, and the equal distance from the center to the point outside here is actually, we call it as radius, which you learn in Form 2, right? Okay, so circle has no edge and also corners, or maybe we call it vertex, because it is a round shape. Okay, no edge means no straight line beside it. Okay, therefore no edges. It is made up of points, and there's no corner, because when there is no side to meet together, then we won't get the corner, or we won't get the vertex. Okay, and it is a closed, it must be closed, two-dimensional curved shape. Two-dimensional means 2D, only got length and width. It means that only got area. Okay, and a circle has infinite lines of symmetry. Okay, infinite lines of symmetry means we cannot count the number of lines of symmetry. There are a lot until you cannot count it. Okay, for example, this is only some that I could draw. You can even draw it smaller until you totally get it, the whole circle become a black color. Okay, so that's why we call it infinite lines of symmetry. Okay, so next we are going to look into the parts of circles. Okay, these are the name of the parts of circle that you have learned in Form 2. Okay, so we will go one by one. Circumference. Circumference is actually the length of the curve which makes the circle. So this length, okay, we call it circumference. It is also called as the perimeter of the circle, 一个圆圈的周长. Okay, and how about radius? Radius is actually any straight line drawn from the center of the circle to any point on the circumference. Your radius could be like this, could be drawn like this, or like this, or like this, or like this, as long as it is drawn from the center to any point on the circumference. Okay? And the radius of a circle is always equal. Diameter. Diameter is a straight line that joins any 2 points on the circumference and passes through the center of the circle. Okay, it is a straight line that joins any 2 points on the circumference, and it must pass through the center of the circle. Okay, next, chord. Chord is more or less like the diameter, but the only different thing is it does not pass through the center. It is a straight line that joins any 2 points on the circumference, but it does not passing through the center of the circle. Okay, so we call it chord. Actually, diameter is the longest chord of a circle. Okay, arc. Arc is actually part of the circumference. Before that, we learned this as circumference, right? So arc is actually part of it, some of it. An arc longer than arc of the semicircle. Semicircle means half of the circle. Okay, the half length of the circle, of the circumference. So if the arc longer than, for example, this one, the dashed line, this arc is longer than the semicircle, so it is called the major arc. Okay, and the arc which is in black color, but this time this one is shorter than the arc of the semicircle, so we call it minor arc. Okay, next, we have sector. Sector is actually the area enclosed by an arc and also two radii. Okay, so this one we call it minor sector, the black one minor sector, and the pink color one we call it major sector. And then we have segment. Segment is actually area enclosed by an arc and also a chord. So the black one we call it minor segment, and the light yellow one we call it major segment. Okay, so we stop here before we enter the angles in a circle. Okay, next we are going to learn angles in a circle, which is totally a new thing for you in Form 3. Okay, so listen carefully. Angles in a circle. Actually, we have two main angles in a circle. Okay, so the first one is angle subtended at the center. Okay, angle subtended at the center. What does it mean by this? It is the angle subtended by an arc at the center of a circle. Okay, you see this angle is at the center and it is subtended by an arc. But how do we get this angle? It depends on how you draw the radius, right? Okay, so it is the angle formed by two radii that were drawn from the center to the circumference of a circle. So this angle is an angle subtended at the center, and the arc subtended by this angle is actually minor arc AB. Okay, so let's say I have another angle, major angle here. So this major angle is also angle subtended at the center, but this time it is subtended by the major arc AB. Okay? Okay, the second angles will be angle subtended at the circumference. Angle subtended at the circumference. This circle is actually quite unclear to you, but this is actually a circle, and this angle is subtended at the circumference because it is on the circumference. This one we call it angle subtended at the center because this angle subtended at the center. Okay, so this one is angle subtended at the circumference. Look at the location. Okay, so it is the angle subtended by an arc, okay, major arc AC at the circumference of a circle. And how do we draw this angle? It is the angle formed by two chords, okay, that were drawn and meet at the point on the circumference. Okay, so what can you see the difference among these angles? If angle subtended at the center, it is angle formed by two radii, okay, drawn from the center. But if it is angle subtended at the circumference, it is the angle formed by two chords. Do you see the difference? This one is two radii, this one two chords. Okay, so these are the main angles in a circle. Okay. Alright, next we are going to learn the properties of angles in a circle regarding angle subtended at the center and angle subtended at the circumference. Okay, so the first one, when you see this kind of diagram, actually this is the properties. Okay, angles subtended at the circumference by the same arc are equal. Okay, let me explain to you. Okay, look at this angle. This angle is angle subtended at the circumference, right? Because it is on the circumference. And then it was drawn by two chords and subtended by arc AB. Okay, so we call this angle subtended at the circumference, and the value for this angle is x. This one, the value also x. Why? Because it is also drawn by two chords and then subtended by the same arc AB. like just now. Okay, you see the blue one, it is subtended by arc AB. The black one, also subtended by the arc AB. And the orange one, also subtended by the arc AB. That's why their values are equal. Okay, so this is the conclusion that you must remember, memorize. Angles subtended at the circumference, this one, by the same arc. If they are subtended by the same arc, okay, so their value will be equal. Okay, their value of the angle will be equal. So this is the first properties. Next, okay, how about this one? Angles subtended at the circumference. Again, look at these two angles. These are angles subtended at the circumference. Okay, because they are drawn by two chords and meet at a point on the circumference. Okay, by the arcs of the same length. This angle is subtended by this arc AB. This angle is subtended by arc XY. If happen to say that the length of arc AB is equal to the length of arc XY, then what can we say about these two angles? They are actually equal. Okay? So if this is A, this is also A. Clear? Alright, next. The third properties. Okay, so this time, what you can see here, this angle is actually angle subtended at the center. Okay, this angle CAB is angle subtended at the center. Why? Because it is formed by two radii and arc CB. Okay, this angle DAE is also angle subtended at the center because it is drawn by two radii. It is formed by two radii and an arc. Okay, and what you can see here, the arc length of CB and the arc length of DE are equal. So what can we say about these two angles? Okay, so here's the conclusion. Angles subtended at the center by the arcs of the same length are equal. Okay, this one is angle subtended at the circumference by the arc of the same length are equal. As long as their arc are equal, then their angle are also equal. Okay, so if this is B, this is also B. Okay, alright. Next one. This is very famous. This one very famous. Especially this one, many students get confused with this. So I'll explain this one. Alright. So angle subtended at the center by an arc. For example, for this case, this angle 2x is the angle subtended at the center by an arc AB. Okay, this angle is actually twice the angle subtended at the circumference. The angle subtended at the circumference by the common arc. You see these two ready. They form an angle subtended at the center. And these two chords, they form an angle subtended at the circumference. Right? So these two are actually subtended by the same arc, which is AB. So there is a relationship between the angles, whereby the center is always twice the circumference to the circumference. So if this is 2x, this one will be x. If this is 100, this one will be 50. If this is 200, this one will be 100. If this one is 200, this one will be 400. Are you clear? Okay. So if, let's say, these two angles are actually subtended by the minor arc AB. How about if it is subtended by the major arc PQ? For example, this one. Okay, so as you can see here, these two radii, we are not going to see it like this, but this time we are going to see it like this. Okay, so 2y is actually angle subtended at the center. Okay, by arc, major arc PQ, right? So this one, the green one, is actually angle formed by chord, two chords. Okay, and then subtended by the major arc PQ. So you see, the way they smile, you see this one, the smile is like this. So the circumference also like this. Only then they will have relationship. This one also like this, smile like this. So the angle at the circumference also need to be small like this. Okay? Only then we can say that they have relationship. And the relationship is the angle subtended at the center is always twice the angle subtended at the circumference. Okay? Next. The last one. Okay. So, angle subtended at the circumference, okay, by diameter in a semicircle is equal to 90 degrees. Okay, for example, angle subtended at the circumference. Okay, as you can see here, this angle is actually subtended at the circumference because it is formed by two chords, okay, and then subtended by arc AB. So this angle is actually 90 degree. When do we say this is 90 degree? Only when it is subtended at the circumference by diameter. Okay, by diameter. Apart from the arc, also got diameter here. And then we can say that this is 90 degree. Are you clear? I repeat, angle subtended at the circumference by diameter is by diameter in a semicircle is equal to 90 degree. Okay? So let's look at some examples regarding the properties of angles in a circle, okay, to help you to have better understanding. Okay, the first one. Okay, look at this diagram. Okay, what can you say about the value of x? So you need to remember, you need to recall back the properties, right? So this is actually regarding the first properties, if you still remember. Okay, so you can see here, what is this? The green color, this is actually chord, right? So this chord, they meet at the point of the circumference. So 44 degree is actually angle subtended at the circumference by arc, by this arc, the blue one, right? Okay, next. It happens that there is another pair of chords, okay? It is also drawn and then meet at the point on the circumference. And this angle x is also angle subtended at the circumference by the arc, the blue arc as well. Okay, so you see they are having this common arc here. The green chord having blue arc, and the orange chord also having blue arc. So they are sharing the same arc. So what can we say about x? X is equal to 44 degree because angles subtended at the circumference by the same arc length are equal. Okay, by the same arc are equal. No need to say length because they are sharing the same arc. Of course, their length are equal. Okay, so x is equal to 44 degree. How about the second one? How about this one? Okay, you see, very obvious. This angle 53 degree is actually an angle subtended at the circumference because it is formed up by chord. Okay, this one also by chord, and then this one is by the arc, the blue arc here. The green one also by the blue arc. Why teacher use the same color? Because they are having the same length. So if they are having the same length, their value are also equal. The value of the angle also equal. Because angles subtended at the circumference by the arc of the same length are equal. So x equal to 53 degree. Okay, the next example. Okay, this is angle subtended at the center, right? The 48 degree is angle subtended at the center, okay, by this arc. And x is also angle subtended at the center by this arc. And as you can see here, these two arcs are actually having the same length. So what can we say about the angle? They are equal. 48 degree. Okay? Because angles subtended at the center by the arcs of the same length are equal. Okay, next. Example is regarding this one. Okay, this time, what can we say about the 20 degree here? This 20 degree is actually angle subtended at the circumference, right? Because it is formed up by two chords subtended by arc of 4 cm here. And this angle x is also angle subtended at the circumference by arc length 8 cm. So maybe you said, teacher, I cannot say that x is 20 degree because their arc length is not equal. Their length is not equal, so I cannot say that x is 20. Correct, you are clever. Their arc lengths are not equal. Of course, their angle also not equal, but they can be proportional. Okay, so talking about proportional is very important for you to remember back how I teach you. Okay, to use my pattern that I always remind you in the class. Okay. Okay, I will use this one. This angle, 20 degree, is actually angle at the subtended at the circumference by arc of 4 cm. So it means that 4 cm actually is equal to 20 degree. So how about the arc length with 8 cm? What is the angle here? Okay, so you see, this block is actually for the length of the arc. And this block is actually for the angles subtended at the circumference. So you need to arrange it accordingly, okay, before you do the calculation. So here's the calculation. To get the value of x, you get the diagonal, okay, 8 cm times 20 degree divided by 4 cm. This is how I always teach you, right? You better use this one because this will help you to save a lot of time. Okay, so the answer is 40 degree. Okay, so the next one, how about this one? This is angle subtended at the center by arc of 15 cm. X is also angle subtended at the center by arc 5 cm. So can I say x equal to 100 degree? No, because the length of the arc are not equal, but they are proportional, right? Angle subtended at the circumference by an arc is proportional to the length of the arc. So again, we will do something like this. Okay, so this time 15 cm is equal to 100 degree. How about 5 cm? 5 cm is equal to x degree. So to get the answer, we need to get x equals to 5 cm times 100 degree divided by 15 cm. So you get the diagonal here, the diagonal 100 degree times 5 cm, and then divide by the leftover, which is 15 cm. So the answer is 33 1/3 degree. Okay? Okay, so we stop here before we enter another example because it's quite long already. Okay, the next one. This is mainly about angle subtended at the center by an arc is twice the angle subtended at the circumference by the common arc. Okay, so for example, this angle, angle x, is actually angle subtended at the center because it is formed up by two radii and subtended by this arc, the blue arc. Okay, so this is angle subtended at the center. Okay, and this angle 56 degree is actually angle subtended at the circumference because it is formed by two chords with the common arc here, the blue one. Okay, so this angle and this angle are actually subtended by the common arc, the blue one. So what relationship among these two? This one is actually 2 times of this one, right? Because angle subtended at the center is twice the angle subtended at the circumference. So x is equal to 2 times 56 degree. Because this one is double of this one, right? So you just times 2. So the answer will be 112 degree. Okay? How about this one? Okay, so again, 120 degree is angle subtended at the center because it is formed up by two radii and arc, and an arc here. And x is angle subtended at the circumference because it is formed by two chords and subtended by the same common arc. 4. Okay, so this angle is actually twice of this angle, right? So in another word, angle at the circumference is half of the angle subtended at the center. So in order to get x, you need to get the center, divide by 2. Okay, so you will get 60 degree. Okay, how about this one? It does not looks like this. So can we apply this one? Of course, you need to look at, are they having the common arc? Okay, so you need to highlight like me just now. Okay, so this angle, okay, is actually angle subtended at the center because it is formed by two radii and also the blue arc here, subtended by two radii and an arc here. So this angle is angle subtended at the center. And this one, the green one, is angle subtended at the circumference because it is formed by two chords and sharing the common arc here. So can we apply this one? Yes, because they are sharing the common arc. Alright, because they are subtended by the common arc. You cannot say sharing, but the way I explain it, I just want you to remember. Okay, but when you want to explain, you need to use the terms, the specific terms in the note here. Okay, so because they are subtended by the common arc. Okay, so the center one is always twice the angle subtended at the circumference. So x is equal to 70 degree times 2, which is 140 degree. And the last one. Okay, so what is the relationship among 2a and a? No. Of course, we need to see whether this one can be applied here or not, right? So the main point is, are they subtended by the common arc? So you do the you see this one? I forgot to do this one. This one is angle subtended at the center by arc. This one. Okay, this one, angle subtended at the circumference, also by this arc. So actually, 2a is equal to a. If 2a is 100 degree, so what is a? A is half of it, so 100 degree divided by 2, so equal to 50 degree. Okay, how about this type? Normally students are very afraid of the major one. Don't worry, okay? Don't be afraid of the major angle. Okay, you just look at the small, the angle small, okay? If they are having the same small, means they are having the relationship. Okay, the angle subtended at the center is twice the angle subtended at the circumference. You can apply that one as long as the way they small are equal. Okay, so this is angle subtended at the center because it is formed by two radii and a major arc here. Okay, the way they small is according to the arc subtended. Okay, and this is actually angle subtended at the circumference also by this arc. So they are actually subtended by the same arc, right? So the angle subtended at the center is twice the angle subtended at the circumference. So S is equal to double of 70 degree. So is equal to 140 degree. Okay, next one. Okay, the question asks you to find x and y. Okay, so let us find x first. Okay, x is actually angle subtended at the center because it is formed by two radii and also arc BD, the minor arc BD. Okay, and then the 70 degree here is actually angle subtended at the circumference by the common arc BD as well, right? So we can set that the angle subtended at the center is twice the angle subtended at the circumference. So x is equal to 70 degree times 2, which is equal to 140 degree. Okay? It's actually the same, right? But the way they draw the diagram is different. You see, it can be turned like this, and it can also be turned like this. So you need to know the concept, but not to go and memorize the diagram. Because you can't memorize the diagram, they can just change it by rotating it. Okay, so you need to remember and understand the concept. Okay, how about y? How do we get y? Okay, in order to get y, you see the way angle y small is like this. Okay, so this is actually angle subtended at the circumference, right? I need to find the angle subtended at the center. That's why I get this one. Okay, so the measured angle BOD is actually equals to 360 minus 140. You will ask, teacher, why do you get the 140? Okay, 1 whole turn is 360, right? So 360 minus x, you will get this one, you will get the measured angle BOD. So you got already your x in the previous question. So you get 360 minus 140, so you get 220. Okay, after you get 220, it means that you already get the angle subtended at the center. Okay, which is 220. And this angle is actually angle subtended at the center by this arc. Okay, and as for y, it is actually angle subtended at the circumference, because it is formed by these two chords and also subtended by this major arc. So they are having the relationship. Angle subtended at the center is twice the angle subtended at the circumference. So now we are asked to find the angle subtended at the circumference, y. So we need to use 220 divided by 2. Okay, so we will get 110 degree. Okay? Okay, in this video we are going to look at some examples regarding the last properties of angles in a circle, regarding the semicircle one. Okay, so this is the properties. Angle subtended at the circumference by diameter in the semicircle is equal to 90 degree. Okay, so let's look at this diagram. Okay, this is actually chord. These are actually chord, right? So they meet at the circumference. So angle x is actually angle subtended at the circumference by this diameter. Okay, and this angle is actually in a semicircle. Okay, so what can we say about this angle? This angle is actually equals to 90 degree. Okay, so x is equal to 90 degree. Are you clear? Okay, only when it is subtended by diameter, then we call it 90 degree. Okay, alright, so now let's look at this example. How do we get x? How do we get the value of x? Okay, as you can see here, this is a triangle, right? A triangle has 3 interior angles. We have 1 angles with value here, 55 degree, and then x. And then this one we don't know. How can we find x if we don't know this one, right? Of course, I need to know this one. So, is this 90 degree? Okay, let's see. Okay, this angle is actually angle subtended at the circumference because it is formed by 2 chords and subtended by diameter. You see, a diameter. And then this angle is actually in the semicircle. So we call this angle as 90 degree. Okay, so now after you get this angle, it is very easy for you to find x, right? So you use the sum of the interior angles of triangle, which is 180 minus 90 and minus 55. So the answer will be 35 degree. Okay, next. How about this one? Okay, much more complicated, this diagram, but actually is actually very simple. Okay, you see, I divide it into two parts, upper part and lower part. Upper part, upper semicircle and lower semicircle. Okay, so this angle is actually angle subtended at the circumference by diameter. You see diameter, and this angle is actually 90 degree because it is in a semicircle. Okay, it must be diameter. This angle must be subtended by diameter in a semicircle. Only then we say that it is 90 degree. So in order to find x, you use 180 minus 90 minus 28 degree, which is 62 degree. Okay, as for y, now we are going to look at the lower part of this semicircle. Okay, so this angle, in order to find y, you need to know what is this angle, right? Okay, so this angle is actually angle subtended at the circumference because it is formed by two chords and by the diameter, the blue one, and also this semicircle, okay, the lower part one, the black one. So it is actually 90 degree. So y is equal to 180 degree minus 90 degree minus 44 degree, and the final answer will be 46 degree. Okay, that's all.